Alright, so today we're going to be casting. And casting is when you have a liquid material, you pour it into a mold and it solidifies. And that can either be a polymer or metal. And we're going to be sand molding today. Now, over 70% of casting is actually sand molding. And because I'm a follower and not a leader, that's what we're going to do. I want to mix it with some water and also a resin to hold the sand together. And I'm also going to put a little bit of parsley in there for some flavor. So you're going to want to mix this around. Make it good. So your mold can be pretty much any shape you want. So with the world as my oyster, I'm going to be creative and make a cylinder. So we're going to use some copper today, and in order to melt your copper down to proper casting time, you're going to want to preheat it up to about 2,000 degrees Fahrenheit. So because my oven won't go to 2,000 degrees Fahrenheit, we're just going to pour some syrup in there and hope for the best. Now there's two types of molding. There's expendable, which uses non-reusable molds such as sand, and there's non-expendable, which uses reusable molds. So the thing about casting is that it will contrast during the solidification. So the mold is going to have to be slightly larger than you expect the finished product to be, which is known as contraction allowance. And also, in order to avoid forming gas bubbles in the mold itself when pouring, you're going to want to have a proper flow. So I'm going to drill some holes in here to let the air flow through. Casting can be used for. It can be used for large items such as this car here, or it can be used on the smallest scale, such as for this pair of bolt cutters. Alright, so this is done, and let's see what we got. Look. We got a mouthpiece. Alright, so that only took me about 2 minutes, but for larger items, it can be a very time-consuming process. Yeah, so that's the casting process. Let's just give this baby a little try. Seems good to me.
This is my video for forming and shaping processes for MAE364. My name is Matthew Infarnato. Let's get started. Forming and shaping are processes widely used in modern society's manufacturing world in order to create products ranging from metal car body parts to plastic water bottles. The definition of forming is when mechanical stresses are imposed on a material in order to achieve preferable plastic deformation. The definition of shaping is when material is removed in order to create desired structure. Forming and shaping can be achieved through various processes. These processes can be applied to ferrous metals, non-ferrous metals, and non-metallic substances such as polymers and ceramics. Many of them are listed in this table if you would like to pause the video. Final forms or shapes that can be achieved are pipework, chamfers, cylinders, cones, angles, hoppers, ductwork, squared or round, transitions, lobsterbacks, and all forms of tubular shapes. For metal shaping and forming, it is important to control the temperature, speed, and lubrication. Forging and rolling can be highly automated and cost-effective, but require highly skilled laborers. The time needed to form and shape metals is between polymers and ceramics due to the necessary higher temperatures. Polymers have varying physical properties, can be produced at high cycle times, require moderately skilled laborers, and require less energy than for metals and ceramics due to the lower temperatures. Injection molding is the popular process of forcing heated material into a mold cavity to produce a shaped part. Lastly, ceramics can be shaped and formed by casting, plastic forming, or pressing techniques. The processes can be automated, but are generally more expensive and time-consuming due to the many steps. Highly skilled workers are considerate of cracking and control the raw material quality and processing parameters.
Joining. Joining is used when joining dissimilar materials or dissimilar parts. This method is generally used on metals and thermoplastics. This process is used to create assemblies or large-scale structures. It can be used for a wide variety of projects such as building large ships and bridges to precise engine parts and delicate jewelry. There are several different types of joining methods including welding, brazing, and soldering. The first is welding, which joins materials together by causing fusion, essentially melting the base metal. This method is used for high temperature joining. Brazing is another metal joining process in which two or more metals are joined by melting and flowing a filler metal into the joint. different from welding in that it does not melt the working metal. Soldering is a commonly used form of brazing. It uses lower temperatures than other brazing methods. This method is used when joining wires or electronics. Welding and brazing are performed at high temperatures, and to ensure safety, you need to use a fire-resistant jacket and welding gloves, as well as a welding helmet. Also be sure not to work around or near flammable materials. The average cost for a welding job is $334. However, it can vary anywhere from $55 to $850 based on the material used and the complexity of the project. It is also worth noting the cost of the materials used to weld. With the correct tools and experience, many jobs will take very little time. Parts can be joined in a matter of minutes. However, welding and blazing heats up the parts enough that you will need to allow time for the parts to cool. You could quench the piece, but this could lead to undesirable traits to develop in the material.
This finishing process can further be broken down into honing, lapping, polishing, burnishing, deburring. The honing is an operation used to produce a fine surface finish on holes. This type of method is commonly used on external cylindrical or flat surfaces and to remove sharp edges on cutting tools and inserts. This method is performed using a cylindrical body that has what they call stones at the end. These stones are made of an abrasive material, and the type of finish that is created by this process can be adjusted by changing the type and size of abrasive used, the speed of rotation, and the pressure used. Lapping is a finishing operation on flat or cylindrical surfaces. Lapping can be used to provide a dimensional tolerance of plus or minus 0.4 micrometers. Polishing is a process that produces a smooth, lustrous surface finish. The two basic mechanisms that are involved in this are fine-scale abrasive removal, to get rid of all the rough surfaces to begin with, and then the softening and smearing of surface layers by frictional heating, which provides that lustrous finish that it has. Burnishing is a finishing technique that helps to remove small imperfections in a material, such as scratches, tool marks, and pits. This technique can also be used to help improve corrosion resistance. Deburring. Burrs are thin, triangular ridges that form along the edges of a workpiece. These burrs can make it difficult to assemble things and can prove to be hazardous to people working on the project. Files, cutting, wire brushing, nylon brushes, abrasive belts, ultrasonic machining, electropolishing, electrochemical machining, vibratory finishing, abrasive flow machining, and thermal energy are all methods in which are used to remove these burrs. Surface treating is used in order to impart specific properties and characteristics on a manufactured product.
Machining is the process of taking a raw material and cutting it into a desired shape, also known as subtractive manufacturing. In this video, you can see a simulation of a CNC milling machine, which is one method of cutting away material with high precision. This process can be performed on a huge range of materials, including wood, metal, plastic, foam, and many others. The precision of this process depends entirely on what equipment you are using and how experienced you are. For example, experienced students manually machining parts at UB can hit a tolerance of a few thousandths of an inch, while people with access to more expensive and precise machines can achieve tolerances of half thousandths, which is extremely precise. This type of manufacturing can also be used to get a relatively smooth surface finish if done correctly. Now, the cost associated with this process depends on the precision you are trying to achieve, the complexity of the part, and of course how much raw material you need. Because this is subtractive manufacturing, you do have to buy more material than you need for the final part. In addition, if the part has a complex geometry, you might need custom tooling in order to get the desired shape. Therefore, this greatly adds to the cost in manufacturing time. Machining time itself varies vastly from project to project. You could simply be drilling holes in a plate or milling an entire crankshaft. However, assuming you don't need to create special tooling, you can start cutting the part out right away. Whereas processes like casting, you first have to develop a mold, which is a lot of time up front. However, once a permanent mold is made, casting is far quicker. Because of this fact, machining would be geared more for parts that aren't going to be mass-produced or that require a smooth surface finish and tight tolerances.